everyone, my topic is design and implementation of lexical analyzer and parser for MiniATC language. This project begins with compiler design concepts. First, we see about aim and objectives. The main aim of this project is to design a lexical analyzer and parser for MiniATC language. What are the objectives? To understand lexical analysis, implement token recognition, design DFS, and validate programs using grammar rules. Next, we see about introduction. Automata theory plays important role in compiler design. A compiler converts source code into machine code. In this process, lexical analyzer converts input into tokens and parser checks whether syntax is correct or not. MiniATC is a simple language created for learning these concepts. Next, we see about MiniATC language. This is the structure of MiniATC language. Every program starts with begin and ends with end. In this program, assignments are written, variables are numbers. For example, x is equal to 10, y is equal to x. Next, lexical analysis theory. It is the first phase of compiler. It reads the program character by character and it converts into tokens. And also it removes space, unnecessary symbols and detect invalid characters. Example begins x is equal to 10. Here it is a invalid because there is no end in the MiniATC language program. Next is finite automata theory. Tokens are smallest meaningful unit of a program. Finite. Finite automata used for pattern recognition and DFA are deterministic automata used in lexical analysis to recognize tokens. It consists of states, transitions, start state, and accept state. It is a DFA for identifier. There are some rules. It must start with letter, contains letters and digits. It is a DFA diagram for identifiers. It is a Q0 state. It accepts letters and move to Q1 state. In Q1 state, letters or digits may be accepted, so it is a self loop. DFA for number rules. It contains only digits. There is no letters in DFA for numbers. Transition. In Q0 state, digit is from digit 0 to 9. It moved to Q1 state and there is only digit, so that self loop in Q1 state. Next, implementation. Import tree. This line imports the regular expression library that is used to identify like tokens like keywords, identifiers, numbers, operators, and separators. Next, lexer function. Lexer function. It is used to perform lexical analysis. It scans the input program and convert it to token using regular expressions. Next, parser function. The function checks whether the token follows the grammar rules of MiniATC language or not. Next, if n is equal to 0, if token I is not equal to begin, this checks whether the token is valid identifier or a variable name. Here we see sample inputs and output generated. I already showed in code. Next, we see in test cases. These are the sample valid and invalid testings. First, begin x is equal to 5 and it is a valid because Program starts with begin and expressions and ends with end. Next is the invalid because not assignment is applied, like these other two examples. Next is context-free grammar. CGF defines the structure of MiniATC program. Program starts with begin, statement follows ID are equal to expression. Next program ends with end. Uh, Next is parser design theory. It is the second phase of compiler. Uh, it works takes the tokens from Lexer, checks the begin and end, validate the statements, ensure the correct syntax. Next, conclusion. This project, lexical analyzer and parser were successfully implemented. This project helped in understanding DFA, regular expression, the context-free grammar, and compiler design concepts. Finally, reference. I will refer some books of Introduction to Automata Theory, Compiler Design, and for code, Python documentation, and some lecture notes, etc. Thank you.